piston first stage. MARES has designed and produces the only conventional piston first stage with the DFC system. Its simple construction and extraordinary toughness are matched by outstanding performance, even at great depths. Let's have a look in order to understand its working principles and unique characteristics. The air arriving from the tanks passes through a sintered filter, filtering out any impurities. The heart of the system is a seal that ensures closure. The clean air enters the high-pressure chamber and from there moves to the balancing chamber toward the second stage. The increase in pressure that is generated also exerts its force on the surface of the piston. The piston is pushed closed on the seat, thus interrupting the flow of air into the balancing chamber. The pressure reached inside the balancing chamber is called intermediate pressure. On the surface at equilibrium, the intermediate pressure is determined by load of the spring and by the high pressure that acts on the piston seat. During the dive, these forces are joined by the hydrostatic pressure, equal to 1 atmosphere for every 10 meters in depth. During inhalation, a pressure differential is created in the balancing chamber. The piston moves, allowing the air to flow toward the low-pressure ports. When inhalation is complete, the piston returns to its initial position, reclosing the passage of air. In the non-balanced version, the incoming pressure acts directly on the piston shaft. The force exerted in the direction of aperture will decrease progressively as the pressure in the tank decreases. As the incoming pressure reduces, the pressure inside the balancing chamber required to close the piston will reduce as well. Ultimately, the intermediate pressure valve is affected by changes in pressure in the tanks.